Can anyone hear me? All right. So this is the first time I've done something like this. So I'm pretty sure I have YouTube set up correctly. Uh, yeah, I'm going to start at 11, give people a couple minutes to get ready. But if you have any questions as I go, type them into the live chat and I'll respond to them. Hey, good to see you. So this is Autodesk Inventor, and it is the main thing I use for modeling hard surfaces, anything that isn't cloth or flesh, basically. Uh, I've got the student version here. Normally I'm on my work account, but this doesn't really work. So let's see. So uh, just as a basic overview, Inventor is entirely done by sketches that are then extruded into the third dimension. Basically, it's one tool repeated over and over again with different variations on that tool. So you start by creating a sketch in the X, Y, or Z plane, and that can be any given shape, rectangle, circle, or anything weird. And then you can extrude them in or out, set distance. And that, in a nutshell, is 90% of the basic Inventor. So after that, you can change these shapes around by putting fillets on them, or drafts, or you can mirror them, just anything at all. And from that relatively simple tool set, you can do pretty much anything. It's just really difficult for more flesh type stuff. Well, in Inventor, the more difficult part is just kind of uh, workflow. Going through it with any kind of speed takes a while, and it can get a little tedious, but it's really efficient. So, for example, if I were to take, let's just do a bolt pistol real quick. At its base, bolt pistol is just a rectangle. Just throw a clip on there. Some nonsense back here. So we would take that, extrude it out. And I'm doing this pretty loose at the moment, but you can do it very exact by measuring your drawings and extrusions. But right now I'm doing this quick, so kind of loosey-goosey. Come on, project. Oh, why are you doing this? Ah, I missed it. There we go. So one of the main annoying things about Inventor is it doesn't always lock onto points correctly. And you have to make sure you have a good area there. Yeah, let's do that for now. So at the start of the hour, I'm going to do this right and do it's a good, decent heavy weapon. But you can see that after a couple minutes, you can start to get pretty much anything together off a basic geometric shape. Well, this program was just because I had access to it at university. um, that's pretty much it, actually. Um, now, I use it a lot in my professional life. I use it 8 hours a day for really dull stuff, girders and buildings, but basically just years of experience. Now, that being said, there's some pretty serious limitations on what it can do. Uh, it's got a very rudimentary freeform mesh system that is okay for more cloth-like applications, but something like a person's face or scales or skin, you would have to do either ZBrush, Meshmixer, or Blender. All right, so let's get started on this heavy weapon. So today I'm going to do kind of a heat gun, and I'm going to start out by calling it, say, 0.2. I'm not used to talking as I do this, so just feel free to ask questions and I'll answer them as I come up, or else it might get kind of dull and quiet. Because right now I'm just going through the basic shapes that I'm going to want to extrude. Do, 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 do. Yeah, that looks about right. So let's bring that to 3D, call it. So right now I'm just blocking out the general shape that I want it to be. I'm not being especially exact with dimensions because I'm not really going off a template. I'm just kind of doing what looks right. That looks okay. And we need a projector on this. I don't know, this looks very weird right now, but once I start hitting a couple buttons, it'll start to come into place. Uh, yeah. So it's not as intuitive as some other programs. Blender, for example, has a very poor interface, but you can pick up the actual modeling in it. Blender, ZBrush, a lot of programs have very similar um, interfaces that are basically just push-pull on a three-dimensional object. In ZBrush, you take a sphere or a cylinder generated by the computer, and then you just push or pull on it until you have a shape that you like. CAD is different. Some people pick it up really easily. Some people it takes a while, just because it's so, I don't want to say exacting, but it can be a pain. This is a silly way to do this cut, but and other people that use CAD will get annoyed at me for it, but at the moment, I'm kind of just typing in numbers based on how something cut or extrusion looks. Oh, that's the problem. I forgot to grab that other side. But if you're copying off a template, you can be very, very exact with it. Oh, you gotta be kidding me. Yeah, and like I said, this is a very silly way of doing this, but for some reason, it's not being very cooperative right now. Let's see if that worked. Nope, we're just gonna have to do this manually. Yeah, undo all that. We'll do that later. Okay. I've never actually used SketchUp. The other thing is, so I wouldn't be able to say. Now, I've heard good things, but no. So what I've done here is I've mirrored my existing piece, and I keep missing previous extrusions. I really should just select them all on the right side and mirror them again. But that seemed to turn out all right. We're going to do that again. Well, that's starting to look like something. So at this point, we're starting to get a shape that works out. And I'll start going through and adding detail. Because you kind of have to do Inventor in sort of in waves. You first block out your basic shape, just what you want it to look like, approximate size, and then you just go through and do a pass for more details and go through and do a pass for more details. And you can continue that iteration as many times as you like. That needs to be larger. Let's call that 3/4 of an inch. Gotcha. In that case, I'd recommend starting. So if you have a .edu email address, which is really easy to get, whether or not you're an actual student, although I would never encourage such a thing, you can get a student version of CAD or a free trial CAD very easily for, I think they offer a student license for 4 years at a time for free. And just start basic shapes. So since it's not a real sculpting program, sometimes it's a lot easier. Uh, huh. Well, it's been a while since I've used Blender, I'll admit. A couple years actually, and I don't recall them doing anything CAD based at the time, but I could be wrong, or I could have just not dove deep enough into it. All right, so I am pretty happy with that basic shape. So let's go around adding little pipes and pieces and such. All right, so for something like this, I've extruded something to the dimension I want it, and now I'm adding curves onto it in order to make it more rounded. Let's call it 0.05. And now we've got sort of a little curvy pipe thing. Let's get some coolant fans on, coolant vents on here. Oh, my my workflow is the thing that gets um, criticized most, uh, but it's kind of the brute force approach to do pretty much anything. There are some guys at work who can do this so much faster, but this is the way I've learned it. That's the way I've kind of gotten used to it. I want that to be shorter. One of the really great things about CAD over other programs is that you can, if you've done something you don't really like I want this to be shorter now, I can just go through the list of operations on the side, pick out any one from the past, and then just cut it down a bit. And then it'll travel through and it'll update, and sometimes it'll throw out an error because you've removed something that it needs to compute. But usually it works pretty well. Thing to remember in designing on this scale is that in order for a detail to be seen, it has to be exaggerated pretty well. Whoop, something went wrong. That's no longer on that center line. So basically, with the dimensional commands, you can nail down anything. Oh yeah, that's the other thing. Sketching is probably the most complex part of this because everything is based on either sketching or extruding. So you've got lines, circles, ellipses, rectangles, and then polygons of various shapes. And then the rest is just making sure all that stays where it's supposed to be. So here I'm going to throw a parallel constraint on that, put a dimension on it, which is still acting like it's a different angle for some reason. This is because I edited that thing earlier in the sequence of events. It's getting confused. That should do it. That's not that important. Looks fine. All right, let's throw maybe a side panel on that. And I know in general what I want the shape to look like, but if I was copying it off something, like if I had a model right in front of me that I really wanted it to look like, then I'd be sitting next to it with a pair of calipers and measuring every little detail, crevice, etc., and cutting it piece by piece. But because I'm kind of doing this free form, I'm just looking at the model, taking a second, deciding what I want to see, and then moving from there. Right now, what I want to see is pipes. So we've made a little pipe piece here. Let's bring that out to 6. And now we want that repeated a bit. So we'll grab that. Call it 7. Oh, what did I do? An error bouncing up from earlier. So the other thing about Inventor that you have to keep in mind is there are 2 main types of files. So this is a part file, and then there are also assembly files. So if we make a new assembly file, we can take our part files, drop them into an assembly file, and then add other pieces to it. So in this case, I'm going to go through my parts libraries. Let's go Terminator parts. I think I've got some good pipe bits in here. Let's do that. That's just a simple sphere, but you can take that and then pattern it across something, and you can choose a straight line or a curve or circle, anything really, and then just 5. And then you've got a neat looking little pipe thing. Now that'll get quick and blow up your Meshmixer with in Inventor, everything's done not in triangular meshes, but as reference objects that it renders sort of one at a time. And I'm not very familiar with it, but when it's exported, this creates a whole lot of little individual mesh pieces. So I'll have to reduce it later, or else it'll go really crazy, like some of those chainmail pieces on the Thunder Warriors. Let's see. We've done. I'm trying to think of really interesting stuff to show off from the software. So if you need edging on armor or something, you can create a rectangle and then go to sweep. In the assembly file, I need to be in the part file. Let's do the same thing, but in the part file where it's supposed to be. And this is less useful for straights as I'm doing it on it, but on sort of funky armor curves and such, this can be a godsend. And then it just creates the outline that you drew, but across the whole surface. Now, this is... can't think of a lot of stuff to talk about this at the moment, so let's ditch this and go to something more interesting. So this is the upscaled version of the rabbit tank. And right now I'm sort of just adding little greeblies and bits to the top, just going across the front and moving towards the back. So I'll just work on that a bit and come up with stuff. Yeah, so let's pull that up actually. Sorry, I'm new to YouTube live stream. I'm not entirely sure how to get this to switch over to my other screen. Anyway, I just use a mouse and keyboard here. I use a 3D mouse at work. Either one works great, but yeah, you just really need a mouse and keyboard. Yeah, a .edu email is all you need. You go to Autodesk's website and then type that in, set up your, I think it's a 4 or 5 year trial. But it's a really solid program, and you can see how everything is just extrusions, fillets, cuts, and even the most complicated models can be broken down into just individual, almost Lego-like pieces just by repeated cuts, extrusions, everything like that. I'd recommend a 3D. It makes a lot of stuff easier, but you can always just click and drag around this view cube over here. Let's see. Oh, the other thing I wanted to talk about was adding other details, because there's stuff that AutoCAD is really bad at. Just really bad at. So let's pull up this side. And just gonna... So it can export to any of the basic 3D creation files, which is nice. STL is what I'm exporting to at the moment. Put that there. Then we'll pull up Meshmixer. Oh, right, you can't see that. There we go. You try to keep YouTube open the other channel so that, and on the other screen, so that I can know what you guys can see and can't see. So Meshmixer is just entirely different build-wise. You've got the same view cube over here, and some of the interface is similar, but how it works on a basic level is very different. So you can create primitive shapes to play around with, but what it really comes down to is sculpt. And this is another push-pull type program. So you can select a brush size, and then strength is how long you have to stay over a part to change it in a different amount. And people can do amazing things in Meshmixer, but it's not my program. So you push stuff, you can pull it around and change it up. Right now I'm using a big brush at a very high strength to make a point, but you can see how you could sculpt stuff like this pretty easily. But what Meshmixer does really easily, and I'm kind of embarrassed I only use it pretty much for this, is adding pipes and cabling. So it's a really, really great little program that lets you grab a surface in Meshmixer and then add pipes and cabling. Pick your radius, pick your the length of the pipe you want to add, whether you want it to go down, choose the direction you want to pull it in, and then you just hit accept, and it'll generate pipes. So for anything, which is something that Inventor should do easily. If I wanted to make a pipe just in that shape in Inventor, I would have to extrude it a short distance, create a tangent line, sweep it around the tangent line, change the direction, move into the XY plane or the XZ plane, and just keep going. And it can be tedious. Let's see what else is here. So Meshmixer is also really great for if you want to do resin printing. Hollow function on it lets you choose the thickness of the model, density of the mesh, lets you pick holes. Let's see, generate holes. So if I wanted to print this on resin, generate holes, please. There we go. So you'd pick your drainage hole location, you'd pick your, reload that. You pick the area that you want it to be. Actually, you know what? Maker's Muse, I think, has a really great tutorial on this. There's no real reason to go over it again. Let's see. Anything else really interesting in Meshmixer I want to go over? Not especially. So let's close this and let's do some basics on ZBrush real quick, because CAD is good, but it can take a while. So after you hit generate holes, it's supposed to create 2 points, just like it did with the pipe, and then you drag them around to where you want them. So for that, you have to know what orientation you're printing it in, and you choose basically the top and bottom, because you have to keep in mind that the air in the part has to be able to flow in to keep the resin level down, and then the resin has to be able able to flow out at the bottom. And ZBrush is being slow and loading. That's the advertisement. I'm sorry. 1 second. I have to step away. Sorry about that. Okay, let's get ZBrush over here. All right, so ZBrush is I almost want to say, more advanced version of the Meshmixer interface. It's great, love it. One of the best parts is that it has the ability to import so much material just to start out with. Basic faces, mechanical pieces, really anything you want. Primitive shapes, you can flip through, choose. And they have a massive library of different creature parts, basic materials. So say you wanted to create a horn, you just drag it, stick it in there, and then you can, it is incredibly useful if you just want to create a quick area of scales, or, you know, just a creature with some eldritch abomination just out of nowhere. I've got to turn symmetry off. So this is just ZBrush Core, which is the basic tools along with the printing import export plugin. And really, so far, that's all I've needed to do faces, cloaks, skin. It's just really, really handy. If I was doing Tyranids, I wouldn't want to do it without this software, just for the sheer ability to create realistic looking parts with. But the main force of this is what it can do custom. So in this brush section, you have all these different brushes and parts that you can pull on, and you have to imagine your base material as kind of just a block that you push and pull on. So click and drag. You can change the size of the brush. You can change the effect radius of the brush. And basically, you're just going to be pushing and pulling on the material again, like in Meshmixer. Can flatten things down, change the shape. But again, this is a really, really great program for soft surfaces. Without there now, I know there are plugins that make hard surfaces and armor-looking things a lot easier to do, but I don't have that because I have CAD for that kind of stuff. But any kind of textured material you want to do, or like if you just want to throw in a face on something, ZBrush is the program you want to be using. There's some random parts on there, and you've got a belt from a pellet from Berserk pretty easily. But I don't have all that much experience with ZBrush because I just started using it. Well, thanks to you guys. Thanks to the support from Patreon. Let's see. No, I don't want to change that. Save that abomination. So I would recommend just using the student email, picking up a copy of Inventor, and just kind of spend a couple hours getting lost in all the different functions and things it can do. Just make a simple block and then just play with all the effects that you can do to it. Unless I think of something else really interesting to say, I'm just going to spend a while adding rivets and parts to this, and you guys ask me questions, and if I have an answer, I'll give it to you. I'm sure if as I continue to do this sort of thing, I'll think of more interesting things to say as I go, but the best advice I can really give on any 3D program is just to open it up, play around with it until you have something that you kind of like, and then just keep messing with it. Don't be afraid to mess up a model by just playing with the different functions that you have available to you. I cannot stress enough the importance of rivets. Rivets are shorthand on any given wargaming terrain to give it some texture and definition. Any kind of vehicle for, conflict or 40K, Sigmar, or War Machine. Rivets are everywhere because they're interesting and they show up well after washes. So never forget to add just boatloads of rivets. Oh, sorry, I didn't glance over the chat. Uh, well, I admit I've been watching a little too much of The Office recently. Classic anime, Cowboy Bebop. It's kind of my thing. Music depends on my mood. I'm kind of a dick, so anything from heavy metal to classical to pop rock from 40 years ago. Yeah, nothing too engaging though. I wouldn't want to watch the new episode of Game of Thrones or something. That'll pull my attention right off of it. Usually stuff I've seen before already. At the level of scale and detail we're talking, it's important not to get bogged down into all the little nitpicky little dimensions, making sure everything's exactly the same. Because you can look at something like this up close and see, yeah, those vent slats are clearly different, but this tank's going to be 4 inches long. So, as far as I know, that's really not possible at all. Let's see. I think this current project has 16 different heavy weapons that you can put on it. Uh, let's see. So this big guy here is going to have a double sponson mount. It's got the top turret, two different weapon mounts on the hull where you can do heavy bolters, missiles, or las cannons. Yeah, no. I'm actually worrying about how I'm going to make up all the different guns that people put on. Uh, the repressor for existence has just an obscene amount of guns on it that are. It's going to look pretty crowded when I model all of them, but I'll figure it out. Oh yeah. Um, well, I realized that I did the wrong base scale most of the way through, so I'm gonna have to redo that anyway. So kind of just decided to use it to show off what the software could do, and then I kind of ran out of ideas with that. It's not the most organized way to do things, but see, I normally work in millimeters. This has done everything inches by default, and when I booted it, I was kind of nervous about this broadcast. I forgot to switch it over to millimeters, so I was typing in dimensions that eh, wouldn't really line up with everything else. So I'll fix it. It'll look cool, but gotta spend some time with the tanks. Now, I know there's ways to make a single rivet in a location. Like if I were to put one down here, I can copy that over to here, copy that down to here, copy that down to here. But from my experience, the software has been pretty temperamental with that, and I don't know if that's just my uh, card acting up or my old computer, but it often crashes if I try to do that too often. So I end up not really trusting the system and just doing them all manually. Oh yeah, always. Now, one thing that you'll find is a pain if you start working with Inventor is that when it exports, um, so STLs are a unitless file type. They'll just have dimensions referencing, you know, 1, 5, 7, whatever, but no word if it's millimeters or centimeters. So you have to check the file when you first export it to see if it's the right size, 10 times too large, 10 times too small, because, excuse me, often programs like Cura will import it and have absolutely no idea what to do with the spelling on it. I try to catch them all, but that's sometimes why some of the models I post are either 10 times too small or 10 times too large. Well, for 3D printed parts, always go with a full base coat before you start. So a lot of printed parts come out with visible layer lines that you can sand through and you might lose detail, or you can hit them with acetone and that'll bring them down a bit. But in my experience, primer and a varnish base coat will always smooth them out without losing too much detail. So honestly, even for stuff on FDM, I normally just paint it normally after the base coat, and that gets rid of a lot of the layer lines you would see. I'm excited about the contrast paints coming from Citadel. Not a paid advertisement, just my opinion. Um, because hopefully that'll make the whole process after basing and sealing a lot easier to do with printed parts. They've inadvertently helped us a lot here, I think. Put this on the wrong layer, so I'm gonna delete it and do a new layer for it. Well, so unless there are any more questions, I'm gonna keep going on this for another 5 minutes, and call it a video. I hope you guys have learned something, and I'll try to do this sort of thing more regularly. So save up questions or ask me in the Discord, and I'll be happy to get to them as soon as I can. No, everything is by a set dimension relative to everything else. When you create a new sketch that isn't based off of something that already exists, it sort of loses its way and it does its best to compensate. But you kind of have to know where everything is in relation to everything else already. It's exclusively just extrusion cuts instead of push pull. No, afraid not. um, you can do stuff, you can ad lib it pretty well, but you still have to have a really good idea of what you're going for, and you have to pick where you start doing something very carefully. So the basic shape of this is all done. This is kind of just the detail pass where I add all this junk in here to make it more interesting to paint up. But yeah. Mm, I don't like how that looks. Let's switch that up again. Yeah, that's better. You can. So this is a part drawing. Uh, Let me pull up a different thing. So you can smash things together and move things from one assembly to another. Like with this side here, these are the grav plates that I did way back for the hunter killer. You can make them individually and then copy them and import them into an assembly and choose where they go in that assembly. And you can drag them around, but it also gives you the option of doing a exact attachment to an existing surface. But you can't do that in a part file. This is only assemblies, groups of parts stacked together. Yeah. So you would do a bunch of different part pieces, like for this. This is an assembly that's made up of a bunch of different pieces. These engines are a separate piece. These plates are a separate piece. The individual treads are separate pieces. Uh, this is a single element, though, which is derived from this smaller one. So this is a single part piece that I've just built on and added to. And then you go up a level and you add the wheels and the treads and the plates and the engines. And then you go up another level and you start adding the hull and the weapons and such. So layers in this are really just uh, assemblies and parts. You can also do this if I close these out. Yep. And you also go down to the base if you can isolate parts and choose to work on just one thing in the existing layer. But yeah, you do need to build and structure your layer sets specifically with this in mind. It's okay. It's not the easiest thing. It helps if you organize your file systems with all of your parts in it in the same manner that you organize all of the different parts and assemblies and sketches. Uh, every part, every grouping, every assembly is its own separate system of organization. As long as you keep that in mind, it's relatively straightforward, but it does take some getting used to. So, in a continuation of the puns, the small one was the rabbit, rapid assault bulk imperial transport, and this is going to be the hare, the heavy assault resistance eliminator, because that's just the kind of person I am. Oh, the other really important thing with extruding and cutting is you can taper your extrusions and cuts. So we'll call this -15, and instead of extruding straight, no, let's bump it up to -20. It becomes a little fin, which you can then pattern down this way and make a whole grill with very minimal input. So something this software is just really good for is if you have uh, rectangular shapes that can be repeated as often as possible. Anything other than that, and it struggles a little bit because, to be fair, it is designed for steel structural work, which it's really great at. But if you go with Inventor, you are going to want some other software to back it up. All right. Well, if there aren't any last minute questions, I think I'll wrap this up. All right. You guys have a good weekend. Let me know if you have any questions in the Discord. I'll try to get back to you. All right.